This session is just a quick sideline about what I call widgets. I can't think of a better name. These are basically common circuits you need all the time while breadboarding, like debounced buttons, LED displays, timers, etc. If you have a widget, you don't need to build that, saving time. In this video, I'll show you 3 breadboard widgets that also work on our retro headers. We were specifically consistent with our 8-pin headers by using pin 1 for VCC and pin 8 for ground. These particular widgets respect that convention. The first one is this simple display board. It uses a 7404 hex inverter to drive 6 LEDs per the 6 input signals. I got lazy with this one and did the board with SMD components. I then had JLC do the boards in assembly. You can see here that 5 boards were only a couple of bucks American, and assembly totaled $750, including parts. Basically free. Just as a recap, you don't need to know KiCad to have any of this stuff made. I've zipped the files for each board and dropped them into the fab folder. These contain the Gerbers representing the copper on each layer and the drill files specifying the size and location of vias, plated and non-plated holes. You simply need to upload these to your favorite fab. If you want JLC to make some retro boards, for instance, download the retro zip, then drop it onto the quote page. The system will analyze the files and allow you to select various options. For the retro itself, I would select chamfering of the connector, and you could optionally add gold plating to the fingers. For the LED widgets, the process is the same. Drop the file and choose any options. You get 5 boards, but you can bump that up or even have them automatically panelize it for more. If you also want JLC to assemble these, then scroll down to the bottom and turn on assembly. Follow the prompts and they'll ask you for a BOM and CPL file, which are also in the fab folder. These are formatted specifically for JLC. The BOM lists parts from JLC stock and the CPL file tells them which parts go where. A few more buttons and in a week or so you'll get a nice blue box. Easy peasy. I just got mine back, so let's build and test one. This is going to be really difficult installing this one header, but we'll get through it together. I put male pins on the retro board, so I'll need to put a female header on this. You can do it either way. Probably safer to put female headers on the retro, then male pins on these. That way you could also use them directly in a breadboard. I can use this in a breadboard, I just need to use a symmetrical interposer, or what I simply call a long pin thingy. You can orient these vertically or horizontally depending on the header or pins you install. Plugging this onto some sites makes little sense visually, like the video or ball counters, but at least it won't blow anything up. We can try this on the credit counter. Ball and play counter. Bias connector. And even this connector with all of the state signals. Pretty cool. The second widget I created is a digit display. This one has a couple of options. You typically want to use 7447s to drive common anode displays because the 7447s can sink a lot more current than 7448s, and they're still made. The first option for this board is using a 7447 to drive a single 7-segment display. You'll get proper digits 0 through 9, then the crazy stuff after that. Another way to use this board is with a custom PLD that can display hex or decimal. you can just install a single digit for hex, or add another to show decimals 0 through 15. Leave this jumper off for hex, or plug it to the left for decimal. You can also plug it to the right to have pin 7 decide the mode. Pins 2 through 6 are input bit weights 0 through 3 respectively. We made this pin convention standard for all of our counter type debug headers. Let's try this on the coin counter first. I'll use decimal mode for that. Really nice. Pull the jumper and we get the proper hex value. Plug one onto the volley counter. I oriented the connector so this one stands up vertically. I'm using hex mode and you can now watch the action. You can even see it jump to max when we hit a high value brick. You'll notice that on the simple LED board I added a second connector site that mirrors the first. Here I added a header and stacked the widgets so I can see both the raw lines and the digit value. The last widget I created is this XY display for ball motion like we had for the breadboard. This just uses two 74138s to demux the ball counter load bias lines and mirrors our motion chart from part 8. We only need one current limiting resistor for each axis because only one LED is lit at a time. Once again, I just had JLC do the whole thing, and all we need to do is add a connector. Plug that onto the bias header. Now we can watch a visual representation of the ball movement and speed. Well, that's pretty cool. You can stick this on any of the other headers. Won't make sense, but it won't blow anything up. Okay, that's it. I dropped schematics, fabrication, and PLD files for all of these onto GitHub, so enjoy. These are my first PLDs, so don't laugh too much. And you know the drill, everything's beerware. I don't care what you do with it, just buy someone a beer responsibly. Thanks for watching.